All right, we're going to conclude section 15.1 in this video. We're going to do another example from the textbook. So we're on page 1003. We are doing number 17, which says in exercises 17 to 14, determine whether f is the gradient of some function, some scalar function f. And if it is, find such a scalar function. All right, and they give us our vector field is f of xy equals e to the y. It's our I component, and x e to the y plus y is our j component. All right, so now first thing that we want to look at to try to figure out if this is if we can find if this is conservative, we want to look at these functions. Are they defined everywhere? So m and n are defined everywhere, and then their partials. So we'll see their partials when we look at the curl. So we're kind of going to do that at the same time. So we need to look at the partial, or we can just actually quickly look at the partial of this with respect to x is 0, which is continuous. Partial of this with respect to y is e to the y, which is continuous. Partial of this with respect to x is e to the y, and then plus 0, which is continuous. And the partial of this with respect to y is just going to be x times e to the y plus 1, which is also continuous. So all the partials are continuous. All partials of m and n are continuous. And then lastly, we need to check the curl of f and see if we get the curl of f is equal to 0. So now curl of f equals, we have e to the y, x times e to the y plus y is 0, because we don't have a k component there. So I, j, k, and then partial with respect to x, partial with respect to y, partial with respect to z. I'm going to go through and do this, and you'll see from this what's going to happen when you have a two-dimensional vector. So here, the partial of 0 with respect to y gives us 0, minus the partial of this thing with respect to z gives us 0. So 0 minus 0, we get 0 there. And then now we look at the j component. The partial of 0 with respect to x gives us 0. The partial of e to the y with respect to z is going to give us 0. So we get 0 minus 0 there. And now, lastly, we ignore this column. The partial of this with respect to x is e to the y plus 0. So we just get e to the y there. And then minus the partial of this with respect to y. So we get it, which is e to the y. So minus e to y there. So when you have a two-dimensional vector and you have to take the curl of it, you're always going to get 0 for your I and your j component, and you'll get just something for your k component. So you can just put zeros there immediately and then just ignore that column and then do this. Look at the partial of this with respect to x minus the partial of that with respect to y, and that's what you're going to get right there every time. All right, now this indeed is the 0 vector. So we know that f is conservative. So f equals the gradient of f for some f. Now what does that tell us? The fact that f is equal to the gradient of f tells us that f sub x equals, so we go back up here, e to the y, and f sub y would have to be equal to x times e to the y plus y. F sub y has to be equal to x times e to the y. plus y. And again, you pick whichever one of these two you want and you integrate with respect to that variable. So I'm going to pick this first one, and I have f equals the integral of f sub x with respect to x. That's the integral of e to the y, but I'm integrating that with respect to x. The integral of e to the y with respect to x, that's just a constant as far as we're concerned. So this equals x times e to the y. We treated y as a constant here, so our constant of integration can have y's in it. So plus g of y. So right now, supposedly, f is equal to x times e to the y plus g of y. So f equals x times e to the y plus g of y. Now we used f sub x to get this information, so we cannot use f sub x again. Now we're going to use f sub y. So we're going to take the partial of this with respect to y, because we know how to take partials. With respect to y, this is a constant, and then times the derivative of e to the y is just e to the y. So that's x times e to the y plus the derivative of this with respect to y is just g prime of y. But we know f sub y must be something. What do we know it must be? X times e to the y plus y. X times e to the y plus y, because that's what we had from the very beginning. So we're going to set this equal to this. So x times e to the y plus y has to be equal to x times e to the y plus g prime of y. All right, so now these cancel, and we get that g prime of y equals y. So g prime of y equals y. And now I'll go ahead and integrate this one. Although you can do it in your head if you want to. You don't have to show this work that I'm going to do, because we need to find what that g of y is. And now we have g prime of y. So g will be equal to the integral of g prime of y with respect to y, which is just going to give us the integral of y with respect to y, which is going to give us y squared over 2 plus c, our constant of integration. And now we have g is this. So we're going to take this and we're going to put it in right here. So we're going to take this right here, put it right there, and then we have our function f. So f equals x times e to the y plus y squared over 2 plus c. And remember, again, you can always check your answers here. So take the partial of this with respect to x and make sure you get what you started with, and take the partial of this with respect to y and make sure you get what you started with, and you know that your answer came out correctly. All right, so we'll stop 15.1 here. We're going to see this process again in 15.3, so we want to make sure that you're comfortable doing this, because we're going to see it in conjunction with evaluating some integrals as well.